Okay, hi everybody. This is section 10.8. We're going to be doing finding the number of outcomes for an event, how many possible things could happen, and the probability of a compound event. So we have two different sections today. First, let's do some vocabulary. A compound event consists of two or more simple events. So we have two different things that we're wanting to put together. And a sample space is the set of all possible outcomes. All right, let's do part one. Part one, outcomes of compound events. We're going to do a tree diagram example first, then we'll do another example. So we have two examples for this part. A greeting card maker offers 3 birthday card greetings in 4 possible colors, as shown below. How many different cards can be made from the 3 greeting card choices and 4 color choices? Make a tree diagram. Now I'm going to say this now nice and loud. Please make sure you copy all of this down, copy the chart, and then do the problem with me. So the question says, how many different cards can we make? Make a tree diagram. So when you're making a tree diagram, you start with the first choices. Our first type is a type of greeting card. Is it going to be a funny greeting card, a traditional greeting card, or a romantic one? So you start, and we're going to abbreviate. I'm going to do H, T, and R. So we have H, we could have T, and we could have R. Those are our first type of card. So that's the first thing we can do. Then after that, each one of these, the humorous one could be printed in blue ink, in green, in orange, or in red. So each one of these are going to have 4 branches coming out from it. Okay, and we call those branches because this is called a tree diagram. Then this one will have 4 branches. And then this one will have 4 branches. So you're listing all the possible choices. So it will be blue, green, orange, red. Blue, green, orange, red. Blue, green, orange, red. So how many different choices? This demonstrates all the choices. You could have a humorous one that's in green. You could have a humorous in red. You can have a traditional in green, and so on. These are all of the possible choices that we just listed. So we count up how many we have. 4, 4, and 4. That means we have 12 different outcomes. This is one way, setting up the tree diagram. Now the next way is called making a list. Making a list example. A pizza shop has regular, deep dish, and thin crust pizza crusts, 2 different cheeses, and 5 toppings. How many different 1 cheese and 1 topping pizzas can be ordered? Make a list of the sample space. Okay, so the first choice we have, now the most important thing when you're making a list is you want to set it up in an organized way so you don't lose any of your options. So the first thing we have would be regular. So we have a regular crust. We have 2 different cheeses. We'll do cheese 1 and cheese 2. So I'm going to do cheese 1. And then there's 5 different toppings. We didn't list any type of toppings here. Let's see. We'll do numbers for those. So topping number 1. Then we'll do a regular crust with cheese number 1, topping 2. Regular crust, cheese number 1, topping 3. I'm going to get more space here because I'm going to run out. Regular crust, cheese number 1, topping 4. Regular crust, cheese number 1, topping 5. So now we're going to do regular crust, still regular crust. Now we're going to do it with cheese number 2 and topping number 1. Regular crust, cheese number 2, topping 2. Regular crust, cheese number 2, topping 3, and so on. How many different 1 cheese and 1 topping pizzas can be ordered? Okay. Now we have to do, we did regular. Now Now we have to do deep dish, and then we have to do thin. So deep dish, D, cheese 1, topping 1. Deep dish, cheese 1, topping 2. Okay, then we have to do cheese 2 now. Deep dish, cheese 2, topping 3. Okay, and then the last one, we do thin crust. Put that in red. I'm going to squeeze one in here and squeeze one over here just because I didn't shift them all down enough. So if you want, you should put all yours right next to each other. Actually, you know what? Maybe I can make some space. There we go, now I have a scroll bar. So we have thin, cheese 1, topping 1. Thin, cheese 1, topping 2. And then we have thin, cheese 2. Wow, so we have all of those. This is making a list of it. I think there was a question here, so let me go over and grab the question. The question says, how many different 1 cheese and 1 topping pizzas can be ordered? So all of these, so each one of these had 5, 10, 15, 20, 25, 30. So our answer would be 30 choices, or 30 pizzas. Okay, now let's do some probability. Part 2, probability of compound events. The fundamental counting principle. Copy all this down. It says, if an event M can occur in M ways, so whatever it happens for the first event, and followed by the event N that it can occur in N ways, then the event, let me grab a marker, then the event M followed by N can occur in M times N ways. That dot means multiplication. M times N ways. Okay, so you're going to multiply however much happens in M times however much happens in N. So let's do 2 problems and then we are done for today. So, number 3, probability. Can you just shut that for 1 second, please? Thank you. Probability of rolling a number cube. So we're doing, and we want to get a 3. The probability of getting a 3 and then getting a head. Probability of getting a 3 is 1 out of 6. Probability of landing on heads is 1 out of 2. 1 out of 6 times 1 out of 2 is 1 out of 12. That would be your probability. The last problem, we're rolling 3 number cubes, 1 through 6. What is the probability of rolling 3 5s? So probability of landing on a 5, landing on a 5, landing on a 5. That would be 1 out of 6 times 1 out of 6 times 1 out of 6. So what you get is 36 times 6, 1 out of 216. We will do a bunch more of these in class. Have a good day.